KOI 5715.01, one of the most promising superhabitable planets ever discovered. In 2016, scientists found what could be evidence of life elsewhere in the universe. Well, not aliens or spaceships, but something even better, an Earth-like planet around a red dwarf star that could support life as we know it. This exciting discovery was made by analyzing data collected by NASA's planet-hunting Kepler space telescope. The planet is designated KOI 575.21, and it orbits a small K-type dwarf star named KOI 5715, located 2,964 light-years away in the direction of the constellation of Cygnus. The star is slightly smaller and cooler than our Sun. The planet itself is about 1.5 times the size of Earth, and it's thought to be rocky like our home planet. And perhaps most importantly, it orbits in the habitable zone of its star, where temperatures are suitable for liquid water to exist. Since then, scientists have continued to gather data on this intriguing world, and they believe it could be one of the best places to search for extraterrestrial life. But there's still a lot we don't know about KOI 5715.01 and its host star. So what do we know so far? Let's find out. KOI 5715.01 was identified in 2015 through an analysis of light curve data obtained by the Kepler space telescope. The data showed that the brightness of KOI 5715 varied periodically, which indicated that something was orbiting the star and blocking some of its light. However, at the time, the planet candidate was classified as a false positive. That's because Kepler had been designed to look for planets around sun-like stars, and it wasn't really equipped to detect exoplanets around smaller, dimmer stars like red dwarfs. Additionally, red dwarfs are known to be very active with frequent flaring events that can mimic the light dimming caused by a planet passing in front of them. So in 2016, KOI 5715.01 was excluded from the final catalog of candidate planets based on the quality of the data. However, in a study published in 2016, researchers analyzed transit timing events from over 2,500 Kepler objects of interest, KOIs, and re-identified KOI 5715.01 as a potential exoplanet. They found that the periodic variations in KOI 5715's brightness were real and that there was a good match between the model and the observed data. This suggested that the object was a genuine exoplanet. The planet has an orbital period of 110 days, which means that it orbits its star once every 110 days. This is much shorter than the orbital period of Earth around the Sun, which is 365 days. As a result, the planet is very close to its star and receives intense heat and radiation. Despite this, the planet may still be habitable because it could have an atmosphere that blocks the harmful radiation and retains heat. In 2018, the NASA Exoplanet Archive re-evaluated the dispositions of hundreds of KOIs, including KOI 5715.01, employing a more varied vetting approach. Rather than depending solely on the Bayesian false positive probabilities, they used a combination of various vetting criteria, such as transit depth, duration, period, semi-amplitude, and transit timing. This comprehensive analysis resulted in KOI 5715.01 being reclassified as a candidate planet with a high confidence level. A study published in 2021 further investigated the system's architecture using data from the Transiting Exoplanet Survey satellite TESS. The study suggested that there might be additional exoplanets orbiting KOI 5715 beyond the previously detected KOI 5715.01. One of these potential exoplanets has a size similar to Earth and resides within the habitable zone of the star, making it a compelling target for future observations. Further research using both theoretical calculations and observational data from telescopes like Hubble and Spitzer have lent substantial support to this claim. KOI 5715 is located in the northern hemisphere of the Milky Way galaxy, approximately 2,964 light-years from Earth. Its right ascension is 20 hours, 21 minutes, 42 seconds, and its declination is 45 degrees, 52 arc minutes, 48 seconds. The star is relatively young, with an estimated age of 6.7 billion years, which is about half the age of the Sun. It has a mass of 0.85 times the mass of the Sun and a radius that is 0.82 times that of the Sun. The star is slightly smaller and cooler than our Sun, and it has a surface temperature of approximately 4,142 Kelvin. It also has a luminosity that is 0.114 times that of the Sun. The planetary system of KOI 5715 has been the subject of numerous studies due to the possible presence of Earth-like planets in the habitable zone of its star. According to recent analyses, the system is likely to have at least 2 planets. The innermost planet, KOI 5715-01, is thought to be about 1.5 times the size of Earth, and it orbits its star every 110 days at a distance of about 0.15 astronomical units. The second planet is somewhat larger, with a radius of 1.7 times Earth's radius and has an orbital period of 240 days. This planet resides farther away from its star at a distance of approximately 0.25 astronomical units. The habitable zone of KOI 5715 extends from 0.15 to 0.27 astronomical units, and it is here that the 2 planets reside. Interestingly, KOI 5715.01 lies just within the inner edge of the habitable zone, while the second planet is located towards its outer edge. This distribution suggests that there could be other planets beyond the currently known ones, potentially forming a compact system with several superhabitable worlds. KOI 5715.01 has garnered significant attention as one of the most promising superhabitable planet candidates discovered thus far. Superhabitable planets are celestial bodies that not only lie within the habitable zone of their stars, but also possess conditions that are arguably more favorable for life than Earth. KOI 5715.01 meets these criteria, making it a prime target for astronomers seeking to understand the potential for life beyond our planet. Its location in the habitable zone indicates that the planet could have liquid water on its surface, a crucial factor for life as we know it. Moreover, its mass and size suggest that it is a rocky planet with a substantial iron core, a feature commonly found in planets that support life. Unlike Earth, KOI 5715.01 experiences higher atmospheric pressure, ranging from 3 to 15 times Earth's standard pressure. This elevated pressure can enhance the stability of certain biomolecules, possibly increasing the likelihood of complex organic molecules forming and persisting. Additionally, models indicate that the planet could have a thick atmosphere containing methane and carbon dioxide, leading to a greenhouse effect that maintains a suitable temperature range for liquid water. KOI 5715.01 Its proximity to its star ensures constant tidal forces that may contribute to volcanic activity and geothermal energy, providing a potential source of heat and energy for living organisms. Furthermore, the star's low metallicity may reduce the frequency of supernovae and gamma-ray bursts in the surrounding area, creating a relatively stable environment for life to evolve. KOI 5715.01 has captured the attention of astronomers due to its potential for supporting life. However, it's important to note that definitive conclusions about its habitability cannot be drawn until more data is collected. Future observations and analysis will help refine our understanding of this intriguing planet and its potential for hosting life. KOI 5715.01 remains an intriguing subject of study for astronomers and scientists. Its discovery has opened up new possibilities for the search for extraterrestrial life and has highlighted the potential for habitable worlds beyond our solar system. While much remains unknown about this distant planet, the exciting prospect of uncovering life elsewhere in the universe makes KOI 5715.01 a compelling target for continued observation and research. The quest to understand the origins and existence of life beyond Earth is a profound and enduring human endeavor. With remarkable discoveries like KOI 5715.01, scientists bring us closer to unraveling the mysteries of the universe and answering the age-old question, are we alone? Thank you for watching this video. Don't forget to subscribe for updates on all our latest videos.